All right, let's talk about something that's quietly become one of the most critical pieces of the entire AI revolution. It's called the Model Context Protocol, or MCP for short. And honestly, it's the hidden engine that's finally making AI truly, truly useful.
I mean, think about it. We have these incredibly powerful AI models, right? But for the longest time, they've basically been brains in a jar. They're geniuses that can reason and write, but they can't actually do anything in the real world. They can't interact with your files, your company's database, or the tools you use every single day. So how do we finally break them out of that jar?
So here's our game plan for this explainer. We're going to start with AI's big connectivity crisis. Then we'll introduce the protocol that's fixing it all. We'll break down how it works under the hood, see who's actually using it, spoiler, it's pretty much everyone, and then we'll peek into the future of AI agents that all of this makes possible.
Okay, first up, AI's connectivity crisis. Let's really understand the problem MCP was designed to solve. Because before it came along, getting an AI model to just talk to a simple tool was, well, it was a chaotic, one-off nightmare for developers.
This slide just lays it out perfectly. On the left, you see the old way, what we call the M by N problem. If you have, say, 5 different AI models and 10 different tools you want them to use, you have to build 5 times 10, that's 50 separate custom-built connections. It's an explosion of work that's just impossible to scale. Now, look at the right. MCP changes the math. Instead of M times N, it's M plus N. Every model just needs to speak one language, and every tool needs to speak that same language. The problem goes from 50 connections down to a much more manageable 15.
And this wasn't just some inconvenience. It had very real costs. Engineering teams were wasting countless hours building the same database connector over and over again. One for Claude, then another for Gemini, then another for GPT-4. These connections were so brittle, the AIs would often just guess how a tool worked and cause all sorts of errors. And security? Oh, it was a total mess. A wild west of custom scripts and hard-coded passwords, just a nightmare to manage.
So, out of all that chaos, we desperately needed some order. And that brings us to the hero of our story, the Model Context Protocol. Now, the most important thing to get here is that MCP isn't a product or a piece of software you buy. It's an open standard. Think of it like a rulebook, a universal language. Just like how every website in the world agrees to speak HTTP, the goal is for every AI and every tool to speak MCP.
And this is just the perfect analogy. Before USB-C, you had that junk drawer full of a dozen different cables for your printer, your monitor, your phone. It was a disaster. Now, one standard connector does it all. That is exactly what MCP does for AI. It creates one universal plug to connect any model to any tool.
And what's wild is how fast this all happened. I mean, after years of everyone struggling with custom connectors, Anthropic introduced an open-source MCP in late 2024. And by 2025, it was already well on its way to becoming the undisputed industry standard. The shift was incredibly rapid.
Okay, so we know why MCP exists. Now let's get into the really cool part. How does this thing actually work under the hood? The architecture is really elegant, and it's built on 3 key roles. First, you have the MCP server. This is the tool itself, the thing that provides the capability. Your database, your calendar, you name it. Then you have the MCP client. This is the part that actually speaks the MCP language and manages the connection. And finally, and this is the most important part, you have the MCP host. This is the container, the application where the AI is actually running, like VS Code. This separation is genius because the host acts as the security guard, getting the final say on what the AI is and isn't allowed to do. MCP organizes all these interactions into 3 really simple concepts. First, resources. This is what the AI can see. Read-only stuff like files or a database structure. Second, tools. This is what the AI can do. These are actual functions like sending an email or running a query. And third, prompts. This is how the AI should think. These are like little recipes or templates that tell the AI how to use its tools to accomplish a task. See, do, and think. It's a super intuitive design. And the protocol is also incredibly flexible. It can run locally, right on your machine. This is perfect for things like developer tools where an AI needs to access your local code. But it can also run remotely, over the web. This is for bigger enterprise stuff, allowing a whole company to connect to one central, secure tool server up in the cloud. You get simplicity and speed locally, and centralization and scale remotely. Now, as soon as you give an AI the power to do things, you have to talk about security. And the #1 threat here is called the confused deputy problem. This is where a hacker could, say, hide a malicious instruction in an email. The AI reads it, gets tricked, and then tells a tool to do something bad like delete all your files.
The tool trusts the AI, but the AI has been compromised. It's become a confused deputy.
So this is the million-dollar question, right? If we're going to give AI agents hands to interact with the world, how do we make sure they don't cause a total catastrophe? Well, the #1 defense is built right into the MCP architecture, and that defense is you. Remember the host application? The container the AI lives in? It acts as a gatekeeper. Whenever the AI wants to do something potentially dangerous, like deleting a file, the host intercepts that request, pauses everything, and pops up a dialog asking you, the human, for explicit permission. You are always in the loop, which means you are always in control.
So, we have a great design and a really solid security model. But a standard is only as good as the number of people who actually use it. And this is where MCP's story gets truly remarkable.
And look, this is not some niche protocol. The absolute giants of the tech industry have thrown their full weight behind it. Google built it right into Vertex AI and Gemini. Microsoft integrated it directly into VS Code and Copilot Studio. Anthropic, of course, is leading the charge. And on top of that, a massive open source community is building thousands of ready-made servers for anyone to use. Let's just be honest, MCP has already won.
So this widespread adoption isn't just about making life easier for developers today. It is about building the foundation for what is coming next.
Because we now have this universal language, we can start building what people are calling headless agents. These are autonomous AI systems that run entirely in the cloud, coordinating across multiple tools without any direct human input. Imagine an agent that monitors your server logs. When it sees an error, it uses one MC server to open a Jira ticket and another to notify the right team on Slack, all automatically, in seconds. This is the real future of automation.
This is the ultimate analogy. Just like TCP/IP created the standard for how computers exchange data, which, enabled the entire internet, MCP is creating the standard for how AIs exchange context and capabilities. It is the foundational protocol for a new internet of intelligent systems.
So if there's one thing to take away, it's this. MCP provides a stable bridge. AI models are evolving at this dizzying breakneck pace. But enterprise tools and data, they change much more slowly. MCP is that essential layer in between that lets them connect, ensuring that as AI gets smarter and smarter, it also gets more and more useful in the real world.
And that leaves us with one final and really exciting question. The protocol is here, the standard has been set, the foundation is laid, so what are we going to build? What new applications, what new automations, what new forms of intelligence will emerge now that connectivity is no longer the problem? The only limit now is our imagination.